Welcome to our explainer. Today, we are tackling one of the biggest questions you can possibly ask. Just how old is our planet? If you're a student or really just anyone who's curious about the world, this is a pretty fundamental piece of the puzzle. So let's get into it. Okay, let's not beat around the bush. The answer, which scientists have worked on for decades, is a mind-boggling 4.6 billion years. I mean, look at that number. That's a 4, a 6, and 8 zeros after it. It's a timescale so vast, it's almost impossible to really, truly get your head around. And a number that big naturally leads to some even bigger questions, right? First off, how can we possibly be so sure about that specific age? And maybe even more puzzling, when you think about what the early Earth must have been like, how on earth did life get started here at all? To solve that first mystery, you have to think of scientists as crime scene investigators. They're basically detectives, looking for ancient clues that are locked away deep inside the Earth itself. They're searching for the planet's fingerprints, left behind billions of years ago. Now, the number one tool in your detective kit is something called radioactive dating. The best way to think about it is like a natural geological clock. See, certain elements inside of rocks are unstable, and they decay or break down at a perfectly predictable rate. So by measuring how much they've decayed, scientists can calculate the age of that rock with incredible accuracy. And our star clue in this whole investigation is the zircon crystal. As Dr. Paul Mueller puts it, these things are the most reliable natural clocks we have. What's so cool about them is that when they form, they trap bits of uranium, but they kick out any lead. Over billions of years, that uranium slowly decays into lead at a perfectly fixed rate. So, the ratio of uranium to lead inside these tiny time capsules gives us an astonishingly precise age for Earth's earliest days. Okay, so now that we've established the age, let's fire up the time machine. Let's travel way, way back and visit the scene of our second mystery, the origin of life. What did this 4.6 billion-year-old Earth actually look like? Well, forget about green fields and blue oceans. The scene was completely hostile. Totally alien. It was a world of constant, fiery, volcanic activity. The surface was basically a churning, molten mess. And the air? It was totally unbreathable. All the evidence points to a thick, toxic atmosphere made almost entirely of carbon dioxide. Think of the crushing atmosphere on Venus today. That's kind of what we were dealing with. Definitely not a friendly place for life. And here's the real kicker. There was no ozone layer. Without that protective shield, the surface was just getting constantly blasted by deadly ultraviolet radiation from the sun. Any fragile life trying to form would have been zapped out of existence almost instantly. So, how could life possibly come from a place like that? It really seems impossible, right? But against all the odds, a series of pretty remarkable events slowly started to change everything. Okay, so a pretty amazing sequence of events started to unfold. First, a chemical haze, kind of like a diet smog, formed in the atmosphere, and that blocked the worst of the UV rays. Then, down in the shallow oceans, clay on the seafloor started acting like a scaffold, or like a molecular assembly line. Here, all the free-floating chemicals could finally get organized and assemble into RNA, a molecule that can carry genetic instructions. And finally, fatty molecules called lipids started forming protective bubbles around the RNA, creating the very first, very basic protocells. And what's truly amazing is that scientists have actually managed to recreate these key steps in the lab. So this brings us to a major cliffhanger in our story. We've got a potential protocell. We have the basic blueprint for life, but the planet is still missing that one key ingredient we always associate with life: oxygen. So how do we get from this point to a world that we could actually live in? The case takes a really dramatic turn with the arrival of a surprise witness, a new kind of life that would completely terraform the entire planet, and, it would change the course of history forever. So let's meet the hero of our story, anaerobic bacteria. These are incredibly simple, ancient life forms that had one crucial superpower. They didn't need oxygen to live. In fact, they could perform photosynthesis. They'd take in sunlight and CO2, and then they'd release a waste product. And that waste product was oxygen. And the impact, as you can see here, was just monumental. For hundreds of millions of years, these tiny organisms were just pumping out oxygen, slowly,
painstakingly, they transformed the atmosphere from that toxic CO2 blanket into the oxygen-rich air we breathe today. And this led to a whole cascade of incredible changes. The oxygen building up in the air created our protective ozone layer, which finally made the planet's surface safe from all that UV radiation. The stage was now set for new, more complex life forms that could actually use all that oxygen to thrive. This whole transformation is called the Great Oxygen Event, and it was the single biggest climate shift in our planet's entire history. So, what does this all mean? Let's zoom out. We followed the clues from a barren 4.6 billion-year-old rock through this toxic volcanic hellscape to the very first spark of life, and then finally, to a world that's capable of supporting us. And the final verdict here seems to be one of just incredible, mind-blowing chance. That delicate process of life getting started, the haze forming, the clay scaffolding, the lipid bubbles, it probably happened over and over again and failed. But once, maybe just once, everything fell into place in exactly the right sequence, at the right time, allowing life to finally get a foothold and eventually to flourish.
It really leaves you wondering, doesn't it? We've managed to uncover this incredible story of transformation from a toxic world to a living planet. But in 4.6 billion years of history, what other amazing secrets are still out there, waiting to be discovered, buried deep in the past of our very, very unlikely home?